All right, welcome. Today we are taking a look at a couple of organelles that are pretty well known, I think. We're going to take a look at, and I'm going to double check here, 6.2, so this will be 6.3. So today, these are cells that are involved in energy conversions. So we're taking a look at. We're going to start with the mitochondria, a pretty well-known energy-producing cell. Kind of looks like a lima bean here. He's made up of two membranes. We've kind of already talked about that. The mitochondria outer membrane, also called the mom. I was like that one. And the mitochondrial inner membrane. Which is called the mem. So the mom and the mem. And the inner membrane is going back and forth and back and forth and back and forth like that. We'll discuss that in just a second. Just wraps around all over the place. Real quick though, so both of these are membranes, phospholipid bilayers. There's two of them. Again, remember why we think there's two of them. The inner membrane, this is the site of the ETC, which you don't have to stress right now. It stands for the electron transport chain. We're going to learn a lot more about that a little bit later. For right now, you just need to know that that is where the energy conversions happen in the ETC. The ETC is where the energy conversions happen. That's on the mitochondrial inner membrane. And that's actually why we have these back and forth, back and forth, back and forth. We call them folds. And those folds have a very specific name, the cristae, to the plural. So it's these cristae or cristae, these folds they're there to reduce space and maximize efficiency. Right? So by going back and forth, remember the inner membrane, that's where the magic happens. That's where we're converting energy. So by going back and forth, we can save some space and maximize our efficiency inside the mitochondria. So the space between the membranes has a name. It's the intermembrane space, which literally translates into between the membrane. Inter means between. So the space between the membranes is the intermembrane space. It has a high H plus concentration, which means it has a low pH. It's very acidic here in the intermembrane space. And finally, the middle of the mitochondria in here is the matrix. It's kind of like a lake. It's a liquid interior. And that's the location of the Krebs / citric acid cycle. For whatever reason, it has two names. I really am not sure why it has two names, but indeed it does. It has two names, the Krebs / citric acid cycle. And that takes place in the matrix. Again, we're going to talk a lot more about that in our next chapter. So don't stress what that is just yet. We'll come back and we'll hit that again next chapter. For right now, you just need to know that that happens in the matrix. One quick note about the mitochondria. All eukaryotic cells have mitochondria. Every year I have students that think, well, plants have chloroplasts and that is their mitochondria. No. Plants have mitochondria as well. They have both mitochondria and chloroplasts. So watch out for that. Commonly missed question is that people think that mitochondria is to animal cells what a chloroplast is to plant cells, and they're not. They're completely different organelles. And that brings us to our second energy conversion organelle, the chloroplast. All right, so our chloroplast, our mitochondria up here, it's kind of like we took our mitochondria, we sliced off the top and we're looking down into it. Our chloroplast, what I'm trying to do artistically here, and I'm not doing a very good job, is I kept it whole. So it's kind of spherical. And I cut into it. I cut a wedge into it so we can look inside of it. And inside of it, we're going to see a whole bunch of, it almost looks like a stack of pancakes. So just like the mitochondria, the chloroplast has two membranes as well. So we got this top outer shell, that's called the outer membrane. And then we've got kind of this other shell, the inner membrane, and that's what we're taking a look at here. It's almost like when you make your bed, you've got your comforter on top and you pull your sheet out just a little bit. So we just see a little bit of the inner membrane, but you have to recognize that it's under there. It's still there. We're just not looking at the whole thing right now. So that's our outer membrane. That's our inner membrane. These here, just one of these pancakes is called a thylakoid. And they are membrane-bound sacs, and it's on that membrane. So, we're talking about a membrane. We're always talking about that phospholipid bilayer. So it's on that membrane. Where the ETC happens. Hey, that looks familiar from up here. You're going to notice there's going to be some similarities between the chloroplast and the mitochondria. Inside the thylakoid, there's a fluid we call the lumen. Has a high H plus concentration, and hopefully we're getting good at this. That means a low pH. Again, similar to part of the mitochondria, working for chloroplast now. An entire stack of thylakoids is called a grana. And they're stacked, much like the cristae were folds back and forth, where these are stacked for reducing space and increasing efficiency. Finally, then there's a liquid inside the chloroplast. So it surrounds the thylakoids, the lumen's inside the thylakoids, the stroma surrounds the thylakoids, and this is the site of the Calvin cycle. Again, you don't have to stress exactly what the Calvin cycle is right now. We will cover that later in a different unit. Right now, you just need to know that the Calvin cycle occurs in the stroma. Plants and algae have chloroplasts. We're running out of room here, trying to squeeze it all in one page. Really ran out of room there. Sorry about that. But what that says is that there are some bacteria that do photosynthesis, but they do it sans the chloroplast. That means without a chloroplast. So if we're talking about chloroplasts, we're really only talking about plants and algae. All right, well, there is your notes for the chloroplast and the mitochondria. Hopefully that helps out. We'll see you all next time.